So when we multiply and divide rational expressions, we're going to follow the same strategies we do when we do it with fractions. So let's practice with fractions first. So remember, when we multiply fractions, we multiply straight across. Right? Numerator multiplies numerator, denominator multiplies denominator. Except, we usually want to look and see, can we reduce, are there common factors either within one fraction or between the two fractions? Is there a common factor on the top and the bottom that we can reduce first before we multiply? So, right, maybe we see, right, 4 does go into 16. They have a common factor of 4. So we cancel that common factor and write down the leftover factors. Right? So what about between, right, what we have left, 4, 15, 27? Do 4 and 15 have anything in common with 27? Well, maybe you know that 3, right? 3 goes into 15 and 3 goes into 27. So go ahead and divide 3 into 15, leaves behind a 5, 3 into the 27, leaves behind a 9, and then again we multiply across. 4 times 5 is 20, and 9 times 1 is 9. So once you've reduced, once you've found the common factors, am I expressing that strongly enough? Once you find your common factors and reduce them, then you multiply across the top, multiply across the bottom. When we have variables, it is very important to, oh my gosh, I know you know the word, factor first. Okay, so multiply and simplify. So here we go. I have 20xy cubed over 3 times 13x divided by 15y squared. So everybody's multiplying. So now we're just going to look for any factors that are common from the numerator to the denominator. So what do we see? Well, let's look at just the number parts first. So 20, 13, do they have anything in common with 3 to 5? 3 to 15. 5, right? So 5 goes into 15 and 5 goes into 20. So we'll go ahead and take the 5 out of the 15. Leaves behind a 3. 5 out of the 20. Leaves behind a 4. And maybe, right, maybe you want to take a regroup step at that point. So let's just go ahead and multiply across the top and see where we are. So I have 4 times x times y cubed times 13 times x. And in the denominator, I have 3 times 3 times y squared. So I don't think I have anything left to do with my numbers. My 4 times my 13, that just is, what is that, 52? And 3 times 3 is 9. Now let's look at the variable parts. So I have an x times another x on the top. So x times x is x squared. I don't have any x squares on the bottom. I have a y cubed still, and I have a y squared. The y cubed and the y squared, those have a common factor, right? I could write both of those as y squared times something else, and everybody else is still multiplying. So 52x squared. So what happens when I reduce that? Right? Well, it's just like, right, dividing like bases. In fact, that's exactly what it is. I'm dividing the like bases, so we subtract the exponents. So 3 minus 2 is y to the first, and that would be on the top because, right, the 3 was bigger, so that's where it ends up. Okay, how about this guy? I have 3 times x plus 5 times x minus 6 divided by x squared minus 5 times 1 over 6x minus 36. So the numerator here is already factored, so let's go ahead and factor our denominators. So again, difference of squares. So x plus 5 times x minus 5. And then 6x minus 36. So this is linear, right? It's 6x to the first. So it's not a difference of squares, but I can look for a common factor, a greatest common factor between 6x and minus 36. And so that'll be 6 times, and we factor 6 out of 6x, leaves behind an x. 6 out of minus 36 leaves behind minus 6. So 6 times x minus 6 is what that factors to. Okay, so here's what we have all together. I have 3 times x plus 5 times x minus 6 times 1. And then my denominator is all of these factors. So this lonely little 6, I'm going to let that live out front. And then I have x plus 5 times x minus 5 times x minus 6. Now and only now that we have everything all factored, can we look for something to cancel. So any common factors. Well, we can do the numbers first. So 6 and 3 over 6, right? They have a common factor of 3. So a 1 for the top, a 2 for the bottom. X plus 5 over x plus 5, right? That cancels. That's just a 1. And then I have an x minus 6 on top and an x minus 6 on the bottom. Again, all multiplying in there, so I can cancel those. And I don't see anything else that's left. I have a 1 on the top left. I have a 2, and I have an x minus 5 for the bottom. So I'm going to get 1 over 2 times x minus 5. This expression here, right, 1 over 2 times x minus 5 is what we get when we multiply and simplify where we started. Okay, for division, how do we divide fractions? Let's do a quick fraction example here. What if I have 2/3 divided by 4/5? Right? How do we divide 2/3 divided by 4/5? 2/3 times by 4ths, right? So we flip and multiply. Flip the second and multiply. Let's see, and I can reduce, right? The 2 goes into the 4 twice. Multiply across the top. 1 times 5 is 5. And across the bottom, 3 times 2 is 6. So for divisions, we flip the second fraction. So reciprocal, right? Reciprocal is the vocabulary word. We flip the second fraction or the bottom fraction, I'll show you that, and then we multiply. So this 2/3 divided by 4/5, I could have written that stacked 2/3 divided by 4/5. Right? So this is the same thing as writing it. If I wrote that out horizontally, 2/3, the numerator goes first, divided by 4/5 at the bottom. So I just have this here. This shows up in a lot of books. So A over B divided by C over D. A over B, times. So the division changed to multiply, and then we flip that fraction, so D over C. And then we just multiply across. So A times D over B times C, if that helps. Okay, so here we go. Looks like there's going to be a lot of factoring. So let's go ahead and start. I recommend that you go ahead and write it as the multiplication first and then factor, just to make sure that you're actually canceling top to bottom, right? So to cancel a common factor, one has to be on the numerator and one has to be in a denominator. So I have 4x squared over x squared plus 4x plus 4 times x squared minus 4, so it's the second fraction that flips, x squared minus 4 over x. So do we see anything to factor? So, right, we're going to factor that trinomial on the first denominator. So I have 4x squared over, so x squared plus 4x plus 4. So multiply to 4 and add to get 4. So those are 2's, right? So x plus 2 times x plus 2. Here we go. So now we're on this fraction. X squared minus 4 divided by x. So the x, When it's a monomial, kind of like the 4x squared is a monomial, you just kind of drag that along. The x a monomial, just drag that along. We'll deal with those last. But now factor that x squared minus 4. So difference of squares, x plus 2 times x minus 2. If you want to write them all together in 1, so 4x squared, monomials go first, x plus 2 times x minus 2. Those are everything in the top. And then on the bottom, this monomial x, I'm going to put that in the front. And then x plus 2, and another x plus 2. So look for your common factors. So between 4x squared and x, those monomials out in front, I can get rid of an x, right? So this x divides into that x squared, and it leaves behind just an x to the first for the top. So the 4, I didn't have a number out in front here that I could use. So I'm going to get a 4x left from this part. X plus 2 times, or x plus 2 over x plus 2, I can cancel those guys. Here I have x minus 2 over x plus 2. They look like they're close. It's like, gosh, can I just cancel and leave behind a minus? And that's not it, right? In order to cancel and leave behind a minus, you're subtracting in the opposite order. So these two are just completely different numbers. So I think we're done. Let's go ahead and gather up what we've got. We've got 4x out in front, and x minus, so times x minus 2. And then in the denominator, x plus 2. All right. So divide. So again, you flip the second. So I'm just going to copy everything down again. Times 10 over x squared minus 25. Let's go ahead and factor everything that's possible to factor. So x squared minus 3x minus 10. So they're going to multiply to negative 10, add to negative 3. X minus 5 times x plus 2. X squared minus 25. You'll notice I go to difference of squares a lot. So x plus 5 times x minus 5. Look for those common factors. I'm going to go ahead and leave them like this because I can't ran out of room. X minus 5 on the bottom, x minus 5 on the top, right? Everybody's tied up in multiplication now. So I can get rid of my x minus 5s. X plus 2, x plus 5, those are just different. Can't do anything with those. The 10 and the 25, I can simplify those guys though, right? Those each have the factor of 5 that goes into them. So factor the 5 out of the 10, it leaves behind a 2. And 5 into the 25, leaves behind a 5. So when I'm done, so now I multiply across, right? So it's a x plus 2 times 2. And move that 2 out in front. 2 times the quantity x plus 2. And then in the bottom, I have a 5 left over times x plus 5. Notice I'm keeping my binomials in their parentheses so that, right, I remember that if I want to distribute, right, the 5 has to multiply everybody. Okay, so 2 more examples. Just perform the operations and simplify. So first one here is the division. You want to pause and try it on your own. So I'm going to go ahead and write it as our multiplication. 18x cubed over x squared minus x minus 6 times, flip the second, so x minus 3 goes on top, 9x goes in the bottom. Okay, we'll come down here and we'll factor. So I've got 18x cubed. So x squared minus x minus 6, multiply to negative 6, add to negative 1. You use one of those tricks. So that looks like negative 3 plus 2. So x minus 3 times x plus 2. Right, now we're multiplying this fraction. My second fraction, my flipped fraction, they're both linear, right? I have a monomial in the bottom. I've got that x minus 3 in the top. There's not really a whole lot to do on that one. So, right, 9x for the bottom. I'm going to go ahead and just put it here in the same one. And x minus 3 I'm going to put in the parentheses because it's that whole binomial, right? So even though it doesn't have parentheses when it's just by itself in the fraction, once it joins the other fraction, it needs some parentheses so that we know it's the 18x cubed that would multiply it. Okay, look for anything that's common. I know you guys all see the x minus 3's. Those are good. And then write the 9 with the 18 behind a 2. And then I have an x cubed on the top and an x on the bottom. This x plus 2, right? You can't mess with that because it's tied up with that plus. So that's going to stay an x plus 2. The only way I could get rid of it is if I had an x plus 2 factor in the top, exactly like that. And I don't. So let's take a regroup step. I have 2x cubed. Then I have an x for right there and x plus 2. So this x can go into this x cubed. Cancels completely out of the bottom, leaves behind a 1 that I won't write, and it takes 1 away from the 3. So my final answer would be 2x squared over x plus 2. There is no more that can be simplified because I do not have an x plus 2 as a factor in the top. Okay, last one. Factor, factor, factor. So b minus 4 times b plus 3 times b plus 3 times b minus 3, 35b cubed. Multiply everybody across. I know sometimes I take the extra step. It kind of depends on how much room I have. b minus 3 over 35b cubed, b minus 4, b plus 3. Right, those binomial factors are the easiest ones to see, aren't they? So b plus 3, those are gone. Now we'll deal with those monomials out in front. So the 7 with the 35 is behind 5. The b and the b cubed. Right, so this time when I cancel, the b squared that gets left is in the denominator. So I'm left with a b minus 3 in the top. And in the denominator, I've got a 5b squared times b minus 4.